In this video, I'll walk you through an optimization problem. Okay, so here we have a box that we want to send through the mail, and according to regulations, the girth plus the length of this package can't exceed 108 inches, and girth means perimeter of the smallest end. So here it would be like if you went all the way around this side of the box. So what's the largest possible volume of these rectangular parcels that we can send by mail? And let's just say for simplicity that it has a square end. And so then what are the dimensions of the package of largest volume? Okay, so this is a kind of a classic optimization problem. And here what we'll see is we'll just break it down into a bunch of smaller parts. So for the first part, let x represent the length of one side of the square end and y the length of the longer side. So let's go ahead and label these. I'll put that in red. So x is here or here if you like, and y is along this longer side. What's the quantity to be optimized in this problem? Well, what we want to optimize is we want to maximize the volume. So what we want to do, I'll write down max to remember that we're trying to look for a maximum value, not a minimum value. For optimization, it will always be maximum or minimum. We're trying to maximize the volume. And volume in this case will be length times width times height. So x squared times y. Now the problem statement tells us that the parcel's girth plus length cannot exceed 108 inches. We'll actually set them equal to that because if it was smaller, if it was say 100 inches, you could always make one side longer and that would always lead to a larger volume. So if we're trying to maximize volume, we'll make the girth plus the length equal to 108. Okay, so what this tells us is that the girth is 2x. No, the girth is not 2x because the girth is all the way around one side. So that would actually be 4x plus the length, the longest side, that's y, and that this is actually equal to 108. Okay, so what we'll do now is we'll solve this equation for one of x or y. It looks like it will be easier to solve it for y. So y equals 108 minus 4x. And the reason that we're doing that is because we would like to get this equation into fewer variables. So we would like it to say volume equals either a function of x or a function of y. You can do it either way, but here we'll do we'll do a function of x instead. Okay, so volume in this case, now we'll write it as x squared times 108 minus 4x because that's what we're substituting in for y. And over what domain should we consider this function? Well, we know x and y are the lengths of sides of the boxes, so of course those are positive. But also we know that 108 minus 4x should also be positive. Okay. So this tells us that x, in particular, let me flip this around, x should be at most 108 divided by 4, which is 27. Okay, so it should be at most 27 inches. That would be if y were 0, then, which is not possible for a box, but then x would have to be equal to 27 inches to get the girth plus the length equal to 108 inches. Okay, so that's a bound. And then find the absolute maximum of the volume of the parcel on this domain that we just established. So the domain, I should clarify, for x would be from 0 to 27 inches. Those are the possible values for x. Okay, so if we go back and we have v equals x squared times 108 minus 4x. Let's go ahead and multiply through. So 108 times x squared minus 4x cubed. Let's take the derivative of that, b prime. That will be 216x minus 12x squared. And then to find the maximum value of a function, any local or relative extrema, we set this derivative equal to 0 to find critical values. So we can factor out an x. So x equals 0 will be one critical value. And then for the other one, we'll have, let's see, 216 equal to 12x. So that will give me x is equal to, let's do this real quick, 18. Okay. And just like we did before, we can think about our number line. We can't go past 0, but in between 0, oh, I wrote 16, I meant 18. In between 0 and 18, if we plug in a value, say 1, into our derivative here, let's see, we'll get 1 times 216 minus 12, so that will be positive. So it's increasing, and then if we plugged in something larger like 20, 19, or 20, we'll get something positive times something negative, so it'll be negative. So that means 18 is our local max, and it also means these endpoints at 0 and at 27 will be less than the value at 18. If you want, you can always check the endpoints, but the fact that it's increasing and then decreasing will tell us that this must be your maximum value. Now, that's the maximum value for x, the best value for x, but we're asked about the dimensions of the box. So the dimensions of the box, x would be 18 inches. What would y be? Well, y will be 108 minus 4 times 18 from up above, which will be, let's see, 36. Okay, so the dimensions of the box will be 18 by 18 by 36.